we're asked to find the derivative using the product rule. This is like our f of x function, and this is like a g of x function. Now there's a reason why we're doing it. We're trying to distinguish two functions of x, because if you have two different functions of x that are multiplying to one another, then the derivative can be found using this. Actually, the textbook says y equals. So the derivative, which can be abbreviated with y prime, which is the same thing as dy dx, by the way. Okay, both those are saying the derivative of y, and it's implied in this notation with respect to x. Okay, so this means the derivative, this means the derivative, same thing. Okay, so we're asked to find the derivative of, this time using the product rule. So if two different functions of x are multiplying, then this is how you would find the derivative. Derivative of the first function times the second function kept the same, plus the first function kept the same times the derivative of the second function. And that rule will apply anytime where you can think of two different functions of x multiplying to each other. Okay, so I can take a derivative of my f of x that I defined. That's nice and quick. I just use the power rule. The 2 comes down and multiplies to the x, and then the power gets reduced by 1. And then the rate of change of a constant is 0, right? So we don't have to add anything else to this. And then the derivative of g of x, the 3 comes down and multiplies, and then it gets reduced by 1. And then the derivative of 1 is 0. So that's the derivative of g of x. And now all you have to do is plug everything in, and you've technically got the derivative. There's just probably more simplifying you could do. G of x is x to the third plus 1. And then f of x was x squared plus 1. And then the derivative of g of x was 3x squared. There's our derivative. It just can be simplified. Then you might be thinking, well, what would happen if I was to multiply this out and then take the derivative? Well, you would get the same thing. Okay, it's sometimes in calculus where the product rule is necessary. In this case, it's not, but the textbook has given us this problem and said use the product rule just to get us warmed up for it. So though I'm just going to clean up my answer. Clean up my answer here. Distribute that 2x. 3x to the fourth plus 3x squared. Then we can combine like terms. 2x to the fourth plus 3x to the fourth. That makes 5x to the fourth. And then we got 3x squared plus 2x. Okay, so if I did everything right, that's the derivative. And again, if you were to multiply this out to one, if you were to multiply these two parentheses to each other, you get x to the fifth plus x squared plus x to the third plus x squared plus 1. That's what it looks like before you take the derivative. And then if you use the power rule, you get the same thing that we got, right? Okay, but that's the idea of the product rule. Two different functions of x, if they're multiplying to each other, take a derivative of the first one times the second one. This is the formula you want to be using.